So to begin with today's session, we will look at the linear regression, the logistic regression, and the multiple linear regression. Okay, first let's go ahead with linear regression. What exactly is a linear regression? Yes, guys? We have already seen what this is. So
Linear regression, it's a linear approach to modeling the relationship between a scale response and one and more norm.
okay. So basically, regression analysis. It's a form of a predictive model. Okay, it's like see when we had the given data, the data samples, and it is scattered in different positions, right? The x and the y coordinate. So we're trying to come up with a mechanism to make sure and or predict such that it is being either classified into different classes of categories, or it is either getting clustered based on its similarities. So you come up with a predictive model. So regression analysis, it is a form of a predictive model technique which will investigate the relationship between the dependent and the independent variable. If you remember the example that we have solved earlier, or the machine learning, the example with respect to perceptron, when we saw with virtual labs, so you had a graph that was created, right? So there was a graph where each and every data point was representing its x and y coordinate. Okay, you have located there. So the x and the y coordinate over here, one forms as an independent variable and the other forms as an dependent variable. A slight change that you perform. So we will explain this with this diagram over here. So it's basically like the one that we explained earlier with virtual labs also. Okay, the example that we saw was, it used to give us a value. So when I tell this is my data point over here, which I'm annotating, so it has a corresponding x value, it has a corresponding y value for that. Okay, in the two-dimensional coordinate, when I represent, there is a y corresponding value and an x corresponding value. So there is something like we tell it to be as a dependent or an independent variable. So when I consider an independent variable, it is basically a type of a variable that changes with respect to, so it is basically whenever I try to increase the value of or decrease the value of it. So when I try to change the value of this particular variable x, okay, in the experiment, okay, it performs, okay, it performs its actions and its effect is basically observed with respect to the dependent variable. So whenever I suppose I make the value, if in y in equation y is equal to mx plus c, okay, mx plus C, if I consider this is the equation of a line, okay, whenever I change the value of x, okay, with the slope and the intercept, obviously I have a value that is going to be changed with respect to the y. Okay, so which means that any effect that happens onto that variable, this becomes a dependent variable. And a value of the variable that keeps on changing, okay, in the given experiment or in the given equation right now, the line equation, this becomes my independent variable. So I have an independent variable along the x component and a dependent variable along the y component, where each and everything is represented here. Okay, so basically the regression analysis, it will investigate the relationship between this. It will investigate, okay, it lies over here, it lies over here. So it seems to look like when I draw a line, okay, a linear regression line that is connecting these points, it will tell me how it is behaving. So it's going to investigate the relationship between the dependent and the independent variables. So the dependent variable is a variable that is being tested and measured in the experiment. Depending on the independent variable, it forms my dependent variable, as we have already discussed. So the equation of the line, when I tell y is equal to mx plus c, okay. So when I have a positive slope, which means that it is a positive regression line. And when I have a negative slope, which means that it is said to be as a negative regression line. And this is a representation of the line with the positive and the negative slope. So this is an example of calculating the least mean square error and the R2 method for the following data set. So we have to draw a linear regression line. Now I want you to take a paper and a pen, start working along with me. I want you to have this problem solved together. So you write down the table, the X and Y, and the corresponding plot the values in the two-dimensional coordinate. I want you to note down this table, X and Y value, that is 1 and 3, 2 and 4, 3 and 2, 4 and 4, 5 and 5, and plot these values in the two-dimensional coordinate space. You guys are done?
Yes, ma'am.
So the step 1, what do we do normally when I get these data points? What is the initial first step that we perform? Find the mean of X and Y. What is the mean of X and mean of Y? Add all the values of X divided by the total number of values. Add all the values of Y divided by the total number of values of Y. So it is 1 plus 2 plus 3 plus 4 plus 5 divided by 5. 3 plus 4 plus 2 plus 4 plus 5 divided by 5. So you will get the mean of X and mean of Y. You have to tell me what is the mean of X. Mean, I'm going to write it as X bar, Y bar,
Ma'am, 3, 4.6.
3 and 3.6.
X.
3 and
4.6.
4.6 or 3.6?
3.6, ma'am.
Oh, sorry, 3.6, ma'am.
Okay. So 3 and 3.6. So we are done with the step 1 now. Okay. So let's go ahead. Yes, 3 and 3.6. Okay. So now my second step is going to be, let me clear it. So my second step is for the given equation, because I have to come up with a linear regression line over here. So y is equal to mx plus c. Okay. I can substitute the values of, or what I'll do here is, in order to find the value of m, the slope over here, I'm going to calculate it using the equation m is equal to summation of x minus of x bar into y minus of y bar divided by summation of x minus of x bar the whole square. I know the value of x, I know the value of mean of x, I know the value of y, I know the mean value of y, and I know the x minus of x bar the whole square. So now I have to calculate the slope value m. So can you calculate it? The x minus of x bar, the y minus of y. I want a tabular column. So the tabular column would be like, so the first is going to be x minus of x bar, y minus of y bar value. Okay, the multiplication of these two will be the third column. Okay, and x minus of x bar the whole square. Okay, give me these values. And the summation of this is going to be So I want these values now. So what is x minus of x bar? Values?
-2, -1, 0, 1, and 2.
-2, -1, 0, 1, and 2. Okay, y minus of y bar?
-0.6,
Hmm?
0.4,
Hmm?
-1.6,
Yes.
0.4, 1.4.
Yes. The multiplication of this. Am I right? (1.2 minus 0.4, 0, 0.4, and 2.8? So I
Yes,
need
ma'am.
the summation of both. Okay, and calculate me x minus of x bar the whole square, squaring of it. So it's going to be 4, 1, 0, 1, and 4. So the summation of it value is 10. What is the summation of x minus of x bar into y minus of y bar? The summation of this?
4.
4. So when I substitute in the formula, 4 by 10 is equal to 0.4. So I've got the value of m now. I've got the value of x and x bar. I have the value of y and y bar. Okay. I have to come up with a linear regression line. So what I'll do here is, let me clear the screen. I'll show you the calculations part. So this is what we have done here previously. Yes, we have done that. Okay. Now what do I do here is, my step 3 is for each and every data point value that I have. Okay. So here I know the y mean value because as I told you, I have the m value. Okay. I have the x bar value. I have the y bar value. Okay. The only thing that I don't know is the c. I don't know what is the value of c. So what I'll do here is I will substitute y bar is 3.6. The m value that I got here is 0.4. Okay, so I have the value of m, and the x value, that is the x bar value, is 3. So I will get the c value here. Just let me know what is the c value now. C is equal to, I have substituted in the equation, 3.6 is equal to 0.4 into 3 plus c. I cannot use the table values right now. That's why I'm using the x mean and the y mean value.
2.4 I got now.
2.4?
Yes, ma'am.
Okay, so
C value.
C value is 2.4. So now I have trained my system. Okay, so I've got the values of m, I've got the values of x bar, y bar, and I've got the values of c. Okay, but now I have to get the predicted value of it, because see, my given data is x was the actual data, and the corresponding value y is my label. Okay, but I have to check out, I'm giving the x value. Okay, when I give the x value, I have to get the predicted value of it, which is the YP. Because I have a system, I have a learned system now. So for the learned system, when I give the value of X as my input, okay, the system will learn, okay, the learning is done by here. I already know the value of M, X bar, Y bar, and C. So my system is learned, okay. So whichever the value of X that I give to it, okay, it has to give me the value of YP, the predicted value of Y. So what do I do now? So I will give only the input of it. So when I tell this equation, right, Y is equal to mx plus C, okay. So I will write this as YP is equal to mx plus C. That is the predicted output. This is the equation of the line, my training function. So my function is ready. So I have the function ready, YP, I have to calculate. I know the value of M, I know the value of C, which I've calculated with 2.4, and I know the value of each and every X, because the X value, I give it to my training system, to the learning, to the linear equation line, Y is equal to MX plus C, I will get YP. So keep substituting the values of X over here. So YP is equal to, M is 0.4, okay, my X value is 1, my X value is 1 over here. So, okay, let me clear the screen and write it neatly. Okay. So what am I doing here? I want to calculate YP. So YP is equal to, I know the value of M. M is 0.4. Okay. I know the value of X. X is 1. Okay. And I know the value of C, which is 2.4. Calculate the YP. So now I'll be getting a new table. Okay. The new table will be X, YP, the predicted output. What is my X here? X is 1, 2, 3, 4, 5. Calculate and tell me what will be my YP for the corresponding X value. 1, 2, 3, 4, and 5. So first I've substituted 1 over here. Next substitute 2, 3, 4, and 5. Tell me the values of YP.
Ma'am, for 1 it is 2.8, ma'am.
Okay, 2.8.
For 2 it is 3.2, ma'am.
2 it is 3.2.
Yes, ma'am.
Okay.
3.6.
3.6.
6.
4.
4.
Okay.
4.4.
4.4.
How do we calculate the loss now? Because we have this linear least mean square error. What does least mean square error mean? If you remember your question, find the least mean square error and the R2 method for the given data set using linear regression, right? So what does that least mean square error mean? We know least mean square error is the loss function where I have my learning system. So I have a predicted value. Predicted value minus the actual value will give me my least mean square error, right? Do you agree?
Yes, ma'am.
So I've
Yes,
calculated
ma'am.
this YP. So I have my Y predicted. Let me clear this and go down to show you the calculation part. So this is what we did. We substituted the values and we got this now. Okay. So for that, then what we did over here is I just plotted this line. Okay. These points I've just plotted over here to see how the linear regression line would come. Okay. And this is what we did. So when I tell the least square error is basically YP minus of Y. Because least mean square error equation, if we remember it, it is basically the predicted value minus the actual value divided, the whole square. This was basically our least mean square error. But when it comes to the R2, we have to calculate the R2, and the equation of R2 is summation of YP minus of Y mean the whole square divided by Y minus of Y mean the whole square. So this is the equation of R2. Okay. So now I have to calculate these values. I already know YP value. I already know Y value. I know the Y mean value also. But only thing I have to do is yp minus of y mean, I have to calculate and make the square of it. And again, y minus of y mean, okay, calculate the value of it and square the value of it, take the summation of it and substitute. So we will be getting the r square. Okay. So basically, what does exactly this r squared mean is that you can see the above graph here. See, the above graph is plotted with the actual and the predicted value of y. If the distances between the actual and the predicted is large, then there is an error. Obviously, if the value of yp minus of y, the whole square, if it is large, then we tell that, okay, there's a lot of error. The least mean square error is more. We have to reduce it. In order to reduce that, we used to update the weights for that, right? Its corresponding input instances, we used to update the weights, which means we have to make sure that our loss function is very, very less. Every time, whenever we go ahead with predicting, we have to make sure that the loss function is very less. So in order to adjust the mean square error, we need to compute r square. So it's basically like a squared measure, how much prediction error we evaluated. Okay. To do so, we will be using this formula. Now, what I want you to do is, I want you to create a table again, okay, with the values. So we already know the x and y value. So I know the x value, I know the y value, I know the yp value, right? So all the three values we know, x value, y value, and the yp value. Okay, yp value, we just now calculated it. Now what I'm doing, I have to calculate the loss, right? That is the least mean square error, that's the R2. So in order to do so, my equation is telling I have to calculate yp minus of y bar. Okay, this is 1. Take the square of it. And again, calculate y minus of y mean value. Okay, and take the square of it. So I will need the value of this, take the summation of this squared value of yp minus of y bar, and again summation of y minus of y bar, the whole square. So I need the values of this and this when I substitute it in r square. If I get a higher value, what do we do? What happens if I get a higher value for that? Okay, first calculate it. Calculate it and tell me what value did you get. So I want the values of this table.
Ma'am, yp minus y the whole square I found, ma'am.
Yeah, tell me.
For the first one, it will be 0.64.
For the first one, it is 0.64.
0.16, second one.
0.16.
0, third one.
0 point?
0, ma'am, that's it.
Oh, it's 0. Okay, fine.
For the fourth one is 0.16 again.
It is 0.16. Okay.
For the last one, 0.64.
Okay. What is the summation value of that?
For y minus y bar the whole square.
Okay, y minus of y bar the whole square. Yeah.
0.36.
0.36.
0.16.
0.16.
2.56.
2.56.
0.16.
Okay, 0.16.
1.96.
1.96. The summation values of it?
Yes, ma'am. Summation value for yp minus y the whole square is 0.32.
Okay, 0.32.
And for minus y bar the whole square is 1.04.
1.04. Okay, so it is
0.32 by 1.04.
Let me just
0.31.
calculations.
Ma'am, the summation is wrong, ma'am.
Summation is wrong? Yeah, even I was just thinking. So I've got,
Is it, ma'am? Is it like a mean, or should I just add it up, ma'am? I didn't mean, if I'm not wrong.
It's 1.6 and 5.2.
yeah,
Okay, I made a
I've
mistake in
got it
that
as
one.
5.2 and 1.6.
Only add.
Only add. Okay, okay. I made a mistake, ma'am.
Just check it, Rahul, because even
I
I've
made
got
a
it as
mistake, ma'am.
5.6. Is it
I made a
right?
mistake, ma'am. I made a mistake. Yeah, this is correct, ma'am. I made a mistake.
Oh, okay, okay. So 1.6 divided by 5.2, I get a value of 0.3. Okay, let me just clear the screen. I hope we are okay with the calculations, right? So we have calculated the r square, which is 0.3. So whenever the value of r square is less, okay, whenever the value of this is very less, which means that it is not a very good fitting line. I mean, it doesn't actually come up with the correct regression line for the given data points. Okay, so it's basically telling you if the value of this is high, something with 0.7, 0.8, 0.9, you know, you can tell that, okay, you have come up with a linear regression line that actually tries to coincide all the data points. Over here on the right hand side, I've just written a smaller figure over here for your understanding. See, basically, when I tell mean values, right? So this is my X and this is my Y. When I tell mean of Y, that is Y bar, you know, there's some value that comes out over here. Like we take the mean value in the sense, I average everything divided by the total number of values. Okay, I will get a mean value of it. So when I'm drawing a line, you know, so this is basically the value of it, the YP that I've calculated, and I have drawn a line for that. Okay, so basically this exact deviation that you see, right, from the mean and the standard deviation, you know, so these values should always try to be lesser. So when these values are less, which means that you are actually trying to coincide this line. So this is actually a very good line. What in case I have drawn a linear regression line like this? Let me take another color and show you. Okay, I've drawn a linear regression line like this. So from the mean, okay, to the particular data point, you can see there is a huge line. Again from here, okay, let me extend this line. So from here to the mean, to the line, you can see there is so much of difference. Again, from here to here, I have this. If I extend this line, from here to here, it is like this. So we have to come up with a line, okay, that actually has this difference very, very less. So even the given problem statement, it is telling, see, the value of it is 0.3. You can still come up with a very better line to make sure that it actually is trying to coincide on those points. So it can be increased in order to get a straight line. So you can again recreate the values of m and y. Okay, so the y is equal to mx plus c equation, the m and c value, if you try to change the slope values of it and the intercept of it, so basically you might get another line which actually coincides with this data set. Okay, but with the first to go, we have got this. But when it comes to your linear regression equation, you know, your lab program, we can see that line creation happening. Okay, it can come up with a best suitable line with the values of m and c with x and y values incorporated in it, coming up with a y prediction. Okay, the least mean square error is basically we calculate the yp over there. So yp minus of y, we make sure that the error value is very, very less in your lab program. Okay, so any doubts here, guys?
No, ma'am, clear, ma'am.
Okay, I think we can stop here for today.